Hello and welcome to your very last pre-AP chemistry lab. Thank you for those of you that joined in to do this optional lab. Again, the reason I wanted to do this is because this concept of Le Chatelier's principle and chemical equilibrium is actually really useful in lots of high-level chemistry courses and topics. So I want to make sure you have this opportunity for those of you that are interested. So the idea here is that you've got the lab handout. You're going to fill that in as I take the data, and then you'll do some processing to kind of make sure this makes sense to you. So you've already done the pre-lab. That's the assumption. If not, pause the video now. Do the first page of the lab handout. That's the pre-lab. The purpose of that pre-lab was to get you to think about the fact that if you have an aqueous solution, you've got a whole bunch of different particles that are actually floating around, things like water, H plus, OH minus, and then the particles of whatever you've mixed in. If it's an ionic compound, it's split into its ions. And then specifically for this lab, you'll see that there's kind of the cool chemical reaction of if you have the chromate ion, CrO4 minus 2, you automatically also have the Cr2O7, the dichromate ion, which is kind of a neat thing. And they're different colors, so we're going to be able to see in this lab which thing we have. So this is the equation we're going to keep referring to. So these are always going to be the reactants. These are always the products. The H comes from adding some acid, so hydrochloric acid. This is your chromate, this is your dichromate, and then the OH will come from adding sodium hydroxide, an OH ion. All right, let's go ahead and start to look at this together. So the first thing it asks to do is just to establish what the colors are of the two things. So I'm going to start with your chromate ion, and I'm going to take about pipette full is what it recommends so that you can see and fill in the observation. So the chromate ion is just kind of a yellowy color, kind of goldenish, but just our plain yellow. And then the dichromate ion is the one that will be sort of your orangey color. So a pretty clear orange, so that will be the difference. So you can see, so the chromate is the yellow and the dichromate is the orange. And we're going to keep those as kind of a reference so that if we're trying to decide if something is closer to the chromate side or closer to the dichromate side, we compare it to the original colors. All right, so the chromate is yellow and the dichromate is the orange. All right, so the first thing I'm going to do is I'm going to take another clean test tube and I'm going to put 5 drops of the chromate into it. And I'm not going to be super picky about the drops. 1, 2, 3, 4, 5. I just want to have enough so that we can actually see it. 3, 4, 5. Okay. So there's my chromate. So starting with that. And then it says, so I'm starting right here. And it says that I'm going to add some HCl to it. So go ahead and make your prediction about what you think you will see. I'm starting with CrO4 and I'm adding H. All right. Okay, let's see what happens. So I'm going to actually do that. So let me try to put hitting it in front of the white so you can see the color a little bit. Okay, so this is what it started as. And then I'm adding just a few drops of that. And right away, you definitely can see that change. So then you know, oh, hey, I was on the reactant side, I added reactant, so it shifted to the product side. And how do we know? Because the product side is the dichromate, which is kind of the orangey color. So for your observations, say that it's more orange. For your explanation, you're using that concept of Le Chatelier's principle. I added reactant, shifted to the product to try to get itself back to being balanced. All right. The next one it asks to do is it says to start with the same test tube, all right? So that same test tube we just used, but this time we're going to add OH ions to it. So again, think about what that would do. So I'm on this orangey side. I'm going to add OHs. What do you predict you will see? Go ahead and make that prediction. All right, and I'm going to add a couple drops of this. So this is my sodium hydroxide. What do you notice when I add that in there? All right, take a look at that. So then now you end up with more of a yellowy color. All right, so write that down for your observations. Again, it was orange and then it now went to that yellowy color. Well, let's think about why that is. I was on the product side. I added more product, so it shifted to the reactant side to get back to being balanced. So for your explanation, again, all you need to say is that. That's that balance of Le Chatelier's principle. Added product, shifted to reactant. All right. Okay, so now we're on step 4, and it says we're going to start with a clean test tube, and we're going to use the Cr2O7. So remember, Cr2O7 is the orangey color. Yep, just making sure I'm in the right spot. So 1, 2, 3, 4, 5. So about 5 drops is good. So I'm starting with that. So A few drops of the Cr2O7 solution into a test tube. Now predict what will happen if I add H's. Okay, so I'm starting on the product side. I'm adding reactant. What do you think is going to happen? Go ahead and make that prediction. All right, let's check it out. So it starts as kind of an orangey color, and then I'm going to add a few drops of the acid. What do you notice? Not really any change in color, because think about it. You added a reactant. If it adds a reactant, it's going to shift to the product side, right? So because these are always present, if these things react, they go to that side, right? So that's an idea, same thing, right? Added reactant, shifted to product. All right, we're on step 5. Go ahead and flip the page. This time I'm going to start with the CrO4, which again, remember, is the yellowy color, right? So I start with a few drops of that, 2, 3, 4, 5, that looks good. So yellowy color, and then this time it says that I'm going to add NaOH. So I got to find my NaOH bottle. Oh, I'm just kind of covering stuff up here. All right, so here's my NaOH. Yep. All right, so now we're going to do a few drops of that. So make your prediction. So here's my NaOH, so you can see it. Or sorry, this is my CrO4. I'm going to add NaOH. So I'm starting on the CrO4. I'm adding product. Predict what you think you're going to see happen. All right, so I'm adding my NaOH. What do you notice? Looks the same, right? Color-wise looks the same, but think about what you did. You started on the reactant side. You added product. Well, if you add product, that's going to react, and it's going to shift to the reactant side. So that's why we see the yellow. Because remember, the yellow is the CrO4. That's the side that we're on. All right, so that gives us kind of just sort of the basics of the back and forth. Le Chatelier's principle says if you stress out one side, it does something to relieve that stress. That back and forth balance, whether it's a change in pressure, a change in concentration, or even sometimes a change of temperature, that is what we are observing. Now, we're using concentration just because that's a really fast, easy lab to do. Now we're going to make it just a little bit more complicated. So we're still going to start with this balanced equation. This is our net ionic equation, but now we're going to add another variable into it. So let's check it out. We're on part 2, step 6. So we're going to start with another test tube, 5 drops of the CrO4. Okay, so remember that's our yellowy stuff. So 5 drops, so 1, 2, 3, 4, 5. So about that. 5 drops of the CrO4, and then now we're going to add 1 drop of NaOH. We've done this before, right? CrO4, add OH, so that means you're pushing the equilibrium to the reactant side. So the goal is we have little to no of the Cr2O7s left, like a really small amount, because you're shifting, you're forcing the shift to the CrO4 side. So go ahead and fill in that blank. So you should see, so think about what you should notice. Will it stay yellow or turn orange? Think about that quick before I do it. I'm adding OH product, and what do we see? Okay, so it stayed that yellowy color, because remember, we added product, shifted to the reactant. So essentially, fill in the blank, I should have all chromate ions, CrO4 minus 2. Now I'm going to introduce the new variable. I'm going to add 2 drops of barium nitrate. So now there's going to be another ion available for maybe something else to happen. Let's see what happens. So I add my barium nitrate. I've got my CrO4. So here we go. Check it out. Add it, and look at that. What do you notice happening there? It's like thick. It's like chunky, right? Precipitate. So I have a precipitate. Go ahead and record your observations. It's kind of like milky yellow looking. I don't know why you had yellow milk. That sounds terrible. But a precipitate, definitely. It's cloudy. You can't see through it. So definitely that is a precipitate. All right, I'm going to adjust some of my test tubes here because I got to use this one again later. All right, so that was step 6. So we created a precipitate when we added a new ion. Something interesting is going on with this equilibrium, right? Now I'm going to take another test tube and I'm going to start with the orangey stuff. So K2R or K2CrO7. 1, 2, 3, 4, 5. So about like that. And then again, I want to get it so that pretty much I only have these ions. So think about what I'm going to add. If I want to force it to go over here, what do I need to add? Yep, something from the reactant side. So I'm going to add my HCl and get that to push the equilibrium over to the product side. So go ahead and fill that in the blank where it says this will shift the equilibrium. So there are essentially only which ions? Which are we forcing? Yep, the Cr2O7. So I add a little bit, and as we predicted, it stayed that orangey color because we were trying to make it so that it shifted that direction. So this time, even though we know these are in equilibrium, I've got a really small amount of that CrO4. So again, I'm gonna add a couple drops of the barium nitrate. Think about what you might see. Make a prediction. Do you think you'll see a precipitate or not? All right, couple drops of that, and doesn't really look any different, right? I mean, it's pretty much the same as it was before. All right, well, that tells us something. Here, I shifted it so that I got a precipitate. Here, I shifted it so I didn't. All right, so then that means look at the next question to kind of think about the chemistry of step 6 and 7. Which is more soluble then? Ba with the chromate or Ba with the dichromate? Take a look at these are your options. This is what the dichromate barium looks like. This is what the chromate barium looks like. All right, well, then it's really easy to tell. This is definitely more soluble because we did not see a precipitate. Okay, then there's this big paragraph on the bottom of 3. Here's basically what it's saying. We want to focus on the precipitate because that's the chemistry that happens. And even though this is an equilibrium of the precipitate and the not precipitate, we're going to write the equation as the dissolving version of this. So we're going to start with this precipitate, which again is the one you did not circle. So start with your barium chromate and show me the two ions it would split up into, the dissolving equation. The barium chromate will be your solid for states of matter, and then both the barium ion and the chromate ion will be aqueous because they are dissolving, right? That's the definition. Dissolving splits into ions, dissolves in water, so aqueous because it's making an aqueous solution. All right, so then now you've got a balanced equation that now takes into account that we've got a new ion present. So then what we need to do is, I got one more exploration and then I got a new equation I want to show you. We're on step 8. So now I'm going to take one more clean test tube and I'm going to put a couple drops or 5 drops of the Cr2O7. So Cr2O7. So this is just this is just the original K2CrO7. So I got a little bit of that. So I haven't did that trick that I did before where I shifted it one side or the other. So we're at complete equilibrium right now. I've got all 4 of these ions floating around in there, plus water and the other spectator ions, right? And I'm going to add just some barium nitrate to that. So let's see what we see happening here. Let me try to hold it in a place where you can see it. There we go. Okay, and then what do we notice there? Oh, it's really hard to see. I don't know if you can tell at all. There are little like chunks of things floating around. Can you see that at all? I'm trying to get it to you. Do you see how it's not completely clear? Like, let me give it an example. So this is what it started as, right? Like this clarity, and then this is what it looks like now. So notice that this one is a little bit cloudy. That is showing you that these CrO4 ions are in fact present. If it was just Cr2O7, when we add the barium nitrate, we wouldn't see any precipitate. It would be super clear like the original one was. But then because we see that little bit of cloudiness, that is the answer for number 8. We see a little bit of a cloudy precipitate. So that tells us that there are some CrO4 ions present, even if there wasn't a lot of them. All right, so that was another kind of little exploration that I wanted to go through. All right, now we're on kind of the end of step 8. So now what we're going to be doing, now that we've explored this idea of adding another ion, what I want to do is I want to do this version of the chemistry equation. So let me get that out of the way so you can see it. So we still have our original equation where we have products or reactants and products, but then now I have this precipitate equation as well, where these are your like downside and this is your upside. Okay, so what we're going to talk about next is, well, what if I do something to this equation? What does that do to this equation? All right, so now we're going to go on to step 9 and 10. Take a look at 9. And right before 9, it just says that we're going to explain what happens to both equations. So you're going to have 2 parts to your explanation. So part 9 says this. We're going to use this double equation. We're going to keep that precipitate test tube from step 6. Remember, that's when we made this. And what we're going to do is we're going to add some HCl. So think about where this precipitate is on this big double equation. And if I add HCl, what does that mess up? What happens? All right, go ahead and try it out. Make your prediction. All right, so then now I've got my precipitate. I'm gonna add HCl and we're gonna see what we notice happening. So take a look at that, add HCl. What do you see? What's going on? What does it look like? Add just a little bit more to make it just a little bit more obvious. All right, look at that. Cool chemical reaction. Oh my gosh, it's so neat. I love this. Okay, let's talk about what happened. There's two parts to it. Remember what this looked like when we started? Rewind the video if you need to. So think about where it started. It started basically up here, right? So I had a precipitate, but then I also had these ions present. So let's talk about the sideways equation, then the up and down equation, because we need to talk about two parts. First, I added reactant, so it shifted to the product. Okay, well, that's one explanation of why it got kind of yellowy or orangey color. Because remember, it started as a really like creamy white or creamy yellow, and now it's definitely golden orange more than it was before. So I know I shifted over there. So that's the first thing. But think about it. If I'm over here, that means I don't have this. Well, if I don't have this, that means that this equation is stressed out and I need more of this to get this back to being balanced. So it needs to shift from here where the precipitate is to down. So we took away these ions, so it shifts down, and that explains why there's no precipitate anymore. So the two parts of number 9 to explain it: added reactant, so it shifted to product. You took away from the downside, so it had to shift down, and that's why we don't have a precipitate anymore, because the precipitate is up here. All right, excellent. So now we're going to screw it up one more time. Oh, actually, there's one follow-up question before we do step 10. Right before step 10 on the last page, or page 5, it says, what happened to the barium concentration? Well, think of it. If I was up here and I shifted down, this also increases. And remember, the brackets mean molarity, so the amount of my barium would have increased because you shifted down. So there's more barium ions than the barium chromate precipitate. All right, now we're ready for step 10. So I'm going to use that test tube that I made in step 7, where I essentially made all of the ions go to this side, and it says we're going to add OH. All right, so think about this equation. I'm starting here, I'm adding OH. What do you think that's going to do to both parts? Make your prediction. And I got to find NaOH here. All right, here we go. So let's see what we see happen. So here's my orangey, just like clear solution. I'm going to add some NaOH, and what do you notice? Oh my gosh, again, this is such a cool chemical reaction. So first of all, you notice that it is cloudy-ish, and you notice that it's yellow. Okay, so what happened? We added product, so it shifted to the reactant. That's the first part. But now there's too much of this, so to get back to being balanced, it needs to shift up. So we know it shifts this direction because it's yellowy. We know it shifts up because we definitely see a precipitate. So that's the cool thing that's happening. So added product, shift to reactant, added to the downside, so it shifts up. How do we know that? We saw the precipitate. So then the follow-up question is, what happens to the barium ion? Well, if I'm shifting this direction, I have less of this than I did before because I'm using this to create the precipitate. You got to use pieces to get pieces, right? So that is the idea. That is Le Chatelier's principle. Thank you so much for doing this lab with me. To continue, there's some additional problems just to kind of practice the writing equilibrium expressions, doing some calculations with equilibrium expressions. But after doing this lab, I hope you have a better understanding of this idea of chemical equilibrium and Le Chatelier's principle, helping you move forward with your knowledge of chemistry wherever your path may take you. Thanks so much for joining in. Bye.